Hello students, I hope you are good, well and fine, and today we will be continuing our discussion on the topic of relation function NCERT exercise 1.1. As we previously discussed the question 1 of this exercise, so here we will be continuing that. So in question 1 part 4, the question says determine whether of these parts satisfies reflexivity, symmetricity or transitivity. Okay, let's see. So first of all, the fourth part says my relation is R defined like this and the set in the set of integers. So set is integers, relation is my subset of z cross z. Integer set will be 0, plus minus 1, plus minus 2, till so on, plus minus till infinity. Okay, now the R is defined as the ordered pair such that the difference x minus y is an integer. Okay, so x comma y such that x minus y is an integer. So this means I'm not going to write or list down all the elements because there are many elements which I cannot able to write. Okay, and this will take forever, so I am just taking my R in this set builder format. Okay, so just check for the reflexivity. So reflexive relations, by definition, this means a comma a must belongs to the R for every a belongs to a. So what is my a? So here, if R is my relation from a to a or a to b, let's say a to b, then a is my this set. So here a is my this integer set. So here a comma a must belongs to R, where a must be from for every a from the set of integers. Okay, so set of integers. So does a comma a belongs to R? Let's see. If a comma a belongs to R, then it must follow this thing, that difference of x and y is an integer. So a minus a is what? 0, and 0 is indeed an integer. So this means a comma a belongs to R. This means our relation is reflexive. Okay, now what? If the relation is reflexive, then check about the symmetricity. Now for symmetricity, a comma b belongs to R, then b comma a belongs to R. So if a comma b, so we already know this is we have. So if a comma b belongs to R, this means by this, from this, if a comma b belongs to R, that means a comma b belongs to the relation R, and relation R, the ordered pair, belongs to R only when then the difference is an integer. So this means a minus b is equals to some integer. Okay, let's say I'm going to name it as k. So a minus b is equals to k. Take multiply minus 1 to both sides. So like this, what you will get this, and after doing some manipulation you will get this. So b, you are from here, you multiply minus 1 to both side, to this and to this side, then you will get minus b is equals to minus k. We know k is my integer, k is my integer, then minus k is also my integer, but of negative or the opposite sign. Yes, say k, if k is 3, then minus k will be minus 3. If k is minus 6, then minus k will be plus 6. So if k is my integer, so does minus k. Okay, so from this I can say that if AB belongs to R, this means A minus B is equals to some integer. This means this implies that B minus A is equals to minus K, which is also some integer. So this means this B comma A also belongs to R. So it is also symmetric. Okay, I hope this is all clear to you. Okay, now what? Now let's check for transitivity. So for transitivity, it is quite clear what we are given. We are given for transitivity. For transitivity, given A comma B belongs to R and B comma C belongs to R. Okay, to show A comma C belongs to R. Is this going to happen or not? Let's see. Okay, so if A comma B belongs to R, so from given things we can take information out is like A minus B is some integer, say k. K is my some integer k1, and from this I can say that B minus C is also some integer k2. Okay, add both of the equation. What I will get? A minus B, B minus C. Adding both my equation, I will get k1 plus k2. After some simplification or manipulation, you will get A minus C is equals to k1 plus k2. This is my some integer. This is some another integer, or the same might be. Okay, then the sum of two integers is equals to some integer. Yes, the sum of two integer is integer. So integer. So this means A minus C is also an integer. So I can say that A comma C belongs to what? A comma C must also belongs to R. So from this I showed that it is transitive also. So reflexive, symmetric, transitive. So my this relation is all reflexive, symmetric and transitive. Okay. Now let's talk about the fifth part, and the fifth part contains further sub parts. Okay, quite interesting problem is the fifth part. The relation are defined in the set A. The set A is of human beings in a town at a particular time. Okay, the R over here, the A part, in a A part, the R is defined as pair of peoples or human beings such that both the human X and Y work at the same place. Okay, so R is the pair of people X comma Y, and both these persons X and Y works on the same place. So same place. Okay, so is it reflexive? Reflexive. Let's see. Reflexive means X comma X belongs to R for every X in A. So take any person in this set A. The set A is the set of human beings in a town at a particular time. Okay, in this set A, does these X or the same person work on the same place? Yes, same person works on the same place. So from this, by this I can say that X comma X or the same person work on the same place. This means X comma X belongs to R. This means this is my reflexive relation. So this is my reflexive relation. Let's check about the symmetricity. So the symmetricity. Okay, so given in symmetric relation, what we are given with? We are given with if A comma B belongs to R, then we need to show that B comma A also belongs to R. So here we are given a comma b belongs to R. This means a comma b belongs to R. This means a comma b work on the same place. Yes, a comma b, as it is given, a comma b work at the same place. Okay, work at the same place. Okay, so does b comma a works at the same place? Yes. If a and b are working at the same place, so does the b comma a works at the same place. So this means b comma a belongs to R by just simple definition. So this means it is symmetric also. Okay, now let's check for the transitivity. So for transitivity, it is quite clear. First of all, let's write what we are given with. So in transitivity, transitive relations or the transitivity given is a comma b belongs to R, b comma c belongs to R. To show a comma c belongs to R. Okay, so we are given with a comma b belongs to R, b comma c belongs to R. From this information or the given information, what I can say that a comma b work at the same place, okay. From this I can say b comma c work at the same place. Yes, work at the same place. If say this is the place, a and b working, a and b are working here, place, the place, a and b are working here. If b is working here, then c is working wherever the b is working. So this means c must be somewhere here, and from this I can see from the visual representation that a and c are also working in the same workplace. So this means, this implies that a and c also work at the same place. Okay, so this means a comma c belongs to R. So by just simple language or simple logical reasoning, I can say that a comma c belongs to R. So this means it is also transitive. So this is my reflexive as well as symmetric as well as transitive. Okay, I hope this is quite clear to you. Let's check for the B part. The B part says X and Y live in the same locality. X and Y lives in the same locality. So are the pair of such persons that X and Y lives in the same locality. Okay, what this means? So for reflexive, X and X, both X and X must live in the same locality. Yes, the same person will live in the same locality. Indeed. So this is my reflexive relation. Second is symmetric. Given if X comma Y belongs to R, to show what we need to show Y comma X also belongs to R. Okay, this means if XY belongs to R, this means X and Y lives in the same locality. Yes, lives in the same locality. This means I can also say that Y and X lives in the same locality, because say this is the locality in which X and Y both lives in. I can also manipulate my words, or I can say with the same effect that Y and X also lives in the same locality. This means Y comma x belongs to R. So it is also symmetric. Now let's talk about the transitive relation. Transitive. Now for transitive relation, what I will do, so first of all start with what we are given with. So we are given with what x comma y belongs to R, y comma x y comma z belongs to R. Then to show x comma z also belongs to R. So we are given with these piece of informations. So from first information this, so this is the locality x and y lives in, okay, and I know z lives in the same locality as of y. This means z also be somewhere over here, and from this pictorial representation I can easily see that the x and z also lives in the same locality. So from this I can say x and z also lives in the same locality. So this means x comma z belongs to R. So this is also a transitive relation. So this is also R S T. Okay, I hope this is very clear to you. Now what? Now let's check for the C part. Now C part, what it says? It says my R is the relation in such way that x and y, two person is related such that x is exactly 7 centimeter taller than y. Okay. So pair of two persons such that x is exactly 7 centimeter taller than y. Yes, x is exactly 7 centimeter taller than y. So this means, what about the reflexive? Reflexive. In reflexive, x comma x must belongs to R for every x belongs to A. Yes. So take any person you want in this set. Does he going to be exactly 7 centimeter taller than himself? No. Any person you take, the height remains the same, not greater than itself. So if x comma x belongs to R, this means x is exactly 7 centimeter taller than x. Does this going to happen? No. Why? Because x and x the same, we are talking about the same person, and the same person has the same height, not taller. Okay, I hope this is clear. The reasoning is clear to you. So this means it is not reflexive. So this is not reflexive. Let's talk about symmetric. Symmetric relation. For symmetric, what we are given? We are given x comma y belongs to R, and what we need to show? We need to show y comma x also belongs to R. Let's see. So x comma y belongs to R. This means x is, this is my x is taller than y, and exactly how? 7 centimeters. So x and y. Okay. Now what? And what I need to show? I need to show this y comma x belongs to R. This means y is taller. This means y is taller than x. And how much taller? Exactly 7 centimeter. So if x belongs to y, this means this is going to happen. No one can deny that. So this means that x is exactly 7 centimeter taller than y. So this cannot be possible that y gets taller, because x, we already know that x is taller than y. So this means it is also not symmetric. Okay. So I hope this is clear to you. So we saw that y comma x cannot be in relation R. So this means not symmetric. Now let's see. Sorry. Okay, I hope the RST, okay. Reflexivity, not there. Symmetricity, not there. Now what about the transitivity? Okay, now the transitivity, for transitivity, x, y belongs to R, okay. Y, z belongs to R, okay. This is the given information. And to show x, z also belongs to R, okay. From this, what I can say, x is exactly 7 centimeter taller, 7 centimeter taller than y, okay. And y, as y is of this height, so I am taking same height like this, y is this. So y is, from this piece of information, y is exactly 7 centimeter taller than z. So y is 7 centimeter taller than z. If you compare x and z, if you compare x and z, how much taller is x going to be? So as you can compare easily from this and from this, you know 14. So x is taller than 14, x is taller than z in exactly 14 centimeter. So we can easily see that if we want to show that this x comma z belongs to R, this means x is exactly 7 centimeter taller than z, but it is not the case. Here x is exactly 14 centimeter taller. So x comma z, so x comma z does not belong to R. Okay, so from this what I can say is that it is not a transitive. I hope this is clear to you. Okay, now let's check for D and E. Let's check together. So for D, the pair of persons in such a way that this x is related to y, such that x is wife of y, okay. So R xy such that x is wife of y. What this means? So for reflexive relation, x comma x must belongs to R. This means x is wife of x. Does this going to happen? No, because if you take any x in A, what was the set A? A is any human being in a town at a given particular time. So this means if I take A as a male, if I take x as a male, okay, so male is not going to wife of itself, or any person is not going to wife of itself. So it is not reflexive. Okay, I hope this is very quite clear to you that x comma x not belongs to R by just definition, because x is not a wife of itself. Now the symmetricity relationship, symmetric relation, given x comma y belongs to R, and to show y comma x belongs to R. What this means, from this piece of information, what I can say is quite trivial, is this, that x is wife of y, okay. can I say that y, so this means that y is husband, y is husband of x. Okay, this means y is not the wife of x. Yes, yes. And what we need to show, if you try to see, what we need to show is y comma x belongs to r. This means y is wife of x. So we already showed that y is not the wife of x, so this is not going to happen. So this means it is also not symmetric. I hope this is also very straightforward reason. Now check what let's check for the transitivity. Okay, so for transitivity it is quite easy. What? Okay, for transitivity, for transitivity, given things xy belongs to r, yz belongs to r, and to show x z belongs to r. Okay, now what? From these information, xy belongs to r, this means x is wife of y. If x is wife of y, this means y is husband, husband, husband. This means, and this piece of information says y is wife of z, y is wife of z, wife, y is wife of z. So as we already know, x is wife and y is husband. This means this cannot going to happen. This means this cannot going to happen, or this means this is not belonging to r. We already saw something like this when xy belongs to r and we don't have anything yz belongs to r. That is, this is going to happen but this is not going to happen. Then we say, in such cases we say that it is transitive. Okay, because xy belongs to r, and for transitive we know xy belongs to r, yz belongs to r, then we say xz, belongs to r. But here we know that xy belongs to r, but there is no information about this. This is not in the set, or we can say this is not in the set. Whenever this happens, we can say that it is not contradicting our any definition. So by definition it is transitive. So it is transitive. So reflexive? No. Symmetric? No. Is it transitive? Yes. Now the last one is quite easy. I am doing it verbally. Let's please follow up. So x is father of y. So for reflexive, does x is father of himself? No. So reflexive is not. Okay. For symmetric, if x comma y belongs to r, then y comma x belongs to r. If x is father of y, does y is the father of x? No. The father is only one way. Okay, so it is the son. Okay, so x is father of y. Okay, we know, but y is son, not the father. So this means symmetric is not there. Let's check for the transitivity. If x comma y belongs to r, this means x is father of y. Okay, and y is father of z. This means x is the x is father of y. Y is father of x. What this means? X is father of y. Okay, x is father of y. Y is father of x. So this means the relationship in between x and y will be of grandfather. So it is also not symmetric. So x is not the father of z. So this means the transitivity also not hold. Okay, I hope this is very clear to you. Okay, so let's see as we saw, the reflexivity, symmetricity, and transitivity were there in these all. Okay. Okay. And in the fifth part, A and B, we saw the reflexivity, symmetricity, and transitivity holds there. But in the C part, no reflexive, not symmetric, and not transitive. But in the D part, we saw it is it was not reflexive, not symmetric, but the transitivity were there. As you recall, in the D part, the transitivity were there. Why? Because the condition of the transitive relation was half satisfied. Okay. And for the E part, the reflexivity was not there, neither the symmetric and nor the transitivity. Okay. So I hope this is very clear to you. So that's it for today. Thank you.